Now we're going to do formulas for hydrates. Hydrates are ionic compounds that have water loosely bound to its crystalline structure. Formulas for hydrates will look something like this, where you have the ionic portion of the compound in front, a little dot, which actually is like adding instead of multiplying like in math, and then you'll have a quantity of water. What we'll be looking for here are going to be the numbers that go in front of each of these parts, where the ionic part would have a assumed 1 here, and then the water would have a 5. These are called coefficients. So what you're going to be doing is you're going to be comparing the moles of the ionic part of the compound with the moles of water. You can read all this a little bit later on, but these are the two main words you're going to be looking at. Your hydrated salt or your hydrous salt is the salt that contains the water. The anhydrous salt is the part without the water. So basically what you'll be doing is you'll be given these two values, the value of the hydrated salt, the value of the anhydrous salt, and if you subtract these two, that'll tell you how much water is present. So let's look, for example, at this problem. Now this is just a percent composition type problem. So we'll kind of run through some of the things here. So I'm going to determine the gram formula mass of this particular hydrate. I have 1 copper that has a mass of 64. I have 1 sulfur that has a mass of 32. I have 4 oxygens, each with a mass of 16. So the ionic portion of this compound has a mass of 160. Then if I go over here to the water, there's two different ways you can do this. The easiest way is we know that you have 2 hydrogens with 1 for its atomic mass, so that would be 2, 1 oxygen with its mass of 16 for 18. And then whatever your coefficient is in front, you'd simply multiply that by the 18. In this case, that would be 90. So our total mass for this particular compound is 250 grams per mole. So if I'm looking for the percentage of water in this compound, then all I have to do is take the mass of the water, which was 90, divided by the total mass of the compound, which was 250, multiply it by 100, and I would get 36% of this particular compound or this particular hydrate is water. Now that's just one type of problem associated with this. Now the next one, we're actually going to look for the coefficient that goes in front of the water. So we have a 5-gram sample of this hydrate. So that would be the CuNO3 2 plus some amount of water. So what we're going to be looking for is the coefficients that go in these blanks. It tells us that if we heat this hydrate, we get 3.9 grams of the anhydrous salt that remains, which would simply be the copper 2 nitrate part. So if I take, I go backwards to where I was, sorry about that, y'all. If I take my 5 grams of the hydrated salt and subtract the 3.9 of the anhydrous salt, that's going to tell me that I had 1.1 grams of water. So this is going to work a lot like the empirical formula. So now the only time I need this hydrated salt is to do the subtraction. Then I want to take the 3.9 grams of the anhydrous salt and compare it with the 1.1 grams of the water. So I'll take my 3.9 grams of the copper 2 nitrate, the 1.1 grams of the water, and just like before when we had our individual elements for the empirical formula, we're going to take these grams and convert it into moles. So I have 1 copper at 64. I have 2 nitrogens at 14. And I have 6 oxygens at 16. So I'm going to add all that together. I'm going to get 188. So So let me make sure I did my math right. All right, so that will be the mass here. So I'm going to put my 188 grams down here to my 1 mole up here. I'll go ahead and calculate. So I have a 3.9 divided by my 188. That's going to give me 0.02074 moles of the copper nitrate. I'll do the same thing with the water. So I know I have 1 mole of water with 18 grams of water. And it will be 0.0611 moles of water. So just like we did for empirical formulas, we take the grams of each part of this compound, get it into moles, and then like we did again, we want to divide both of these by the smallest. So the 0.02074 is the smallest. That's going to give us 1 mole then of the copper 2 nitrate portion of the compound. Three moles of this one, of the water. Now that I have whole numbers, these are going to be the coefficients that go up here in my formula. So to review real quickly, you'll get your mass of your hydrate. You'll get your mass of the anhydrous salt. If you subtract those two values, you'll find your mass of your water. Then you want to take the mass of the anhydrous salt only, convert it into moles. Mass of the water, convert it into moles. Divide both by the smallest. And then that will give you the coefficients that will go in your formula here.